Hey there, this is Mr. Alexander, and I'm here today to talk to you about advanced characteristics of rational functions. And I want to start right here. Y equals 2 times 1 over x. Well, hopefully you recognize that is a vertical stretch by a factor of 2. I just want to generate a table of values for that really quick. If I go to my calculator, I can get the values pretty easily. I just type in 2 times 1 over x. Go to the table here. I need x equals -9. So that's -0.222 repeating decimal, which is equal to -2 over 9. -4 is -0.5, which is equal to -1/2. And if I put in the -0.5, I get -4. Put in 0, that's undefined, or an error if you're a calculator. If I put in the 0.25, I get 8. If I put in the 3, I get 0.6 repeating decimal, which is 2 over 3. And if I put in a 7, I get 0.28571, which is, that's just equal to 2 over 7. So I've got some values here for a vertical stretch by a factor of 2. And I want to go ahead and do the same thing, but this time I want to do it for this transformation here, which you hopefully recognize as a horizontal stretch by a factor of 2. Okay, because remember the b value is 1 over b, so we have to do 1 over 1/2, which is 2, to get the factor. So I'm going to do the exact same thing in my calculator, but this time I'm going to change it to 1 divided by 1/2 times x. And I'm going to generate a table of values from that. So I've got the same values already typed in there. So it's -0.222 repeating decimal, which is -2 over 9. -0.5, which is -1 over 2. I've got -4. I've got undefined. I've got 8.6 repeating decimal, which is 2/3, and then finally 0.28571, which comes out to be 2 over 7. So here's the question. Looking at these two tables, what do you notice? And hopefully you realize that these two tables are the same. Okay, that's interesting. Let's do the same thing down here really quick and identify the transformation here. This is a vertical compression by a factor of 1/3. And same table of values. I'm just going to change this to a vertical compression of a factor of 1/3. So I'm going to do 1 over 3 divided by x. And I'm going to grab the table of values here. And I've got 0.037, -0.0833. I've got -0.6667. I've got undefined. I've got 0.25 is 1.3 repeating decimal. I got 0.1111. That's just 1 over 9. And I've got 0.04762. You can probably see where this is going by now, because right here I've got a horizontal compression by a factor of 1/3, because 1 over 3 is 1/3. And so if I type that in the calculator, 1 divided by 3x, better put that in parentheses, 3x, like that, generate the table of values, and look at that. It's exactly the same. I'm not even going to write it down this time. So what's the conclusion that we can draw from this? Well, a horizontal stretch is the same thing as a vertical stretch. And equally, a horizontal compression is equal to a vertical compression. So you don't need to write one or the other. You just pick one. Don't write them both. Why might this be the case? Well, it's because of the algebra. If you'll notice, we did 2 times 1 over x and 1 over 1/2 x, like that. Well, if you simplify this, that's simply equal to 2 over x. And if you simplify this, remember when you divide by a fraction, you flip and multiply, so we've got 1 over x times 2 over 1. which is equal to 2 over x. So you can see, algebraically, they're exactly the same, and that's why that's the case. So when we come over here and we're identifying transformations, you might be inclined to say, oh look, there's a vertical stretch and a horizontal compression. But it's not the case, because we can do some simplification. So if I rewrite this as negative 2 over 5x plus 2, I could rewrite that even further to be negative 2 over 5 times 1 over x plus 2, like that. So, since it's a fraction out front, I'm going to call this a vertical compression. So all of this turns into a vertical compression by a factor of 2/5. It's also a reflection. And then that plus 2 right there, that makes it go left 2. So that's the idea here. We're not going to have horizontal stretches and vertical stretches. We're not going to have vertical stretches and horizontal compressions or anything like that. Just pick one or the other. It's either vertical or horizontal. You really shouldn't have both once you work out the algebra. Let's do a couple more so you can see that a little bit more clearly. So here, notice that there's a 1/2 in the bottom of the fraction there. So I can rewrite that as 1/4 times 2 over x. And all of that's plus 4. Well, notice we got a fraction here. So I can move that 2 over here, and it's going to be 2 over 4. So this is going to simplify to 1/2 times 1 over x plus 4. So I don't have, in the original problem here, I had a vertical compression and a horizontal stretch. But when I work out the algebra, I just end up with a vertical compression of 1/2. So that's what I'm going to call it. It's a vertical compression of 1/2, and it goes up 4. All right, let's do some more like that. So here, we've got 4 divided by 3x minus 15. Well, you might recall that we need to factor out this b value before we can do anything else. So I'm going to do 4 over 3 times x minus 5 minus 1. And then I've got a 4/3 here, so I'm just going to go ahead and bring that out front. 4/3 times 1 over x minus 5 minus 1. All right. So what are the transformations that we have? Well, that 4/3 is now a vertical stretch because it's greater than 1. So I've got a vertical stretch of a factor of 4/3. I've got this x minus 5 down here, which means it's going to go right 5. And then I've got this minus 1, which means it's going to go down 1. All right, let's just do one more like that. And I'm looking at this one. This one's a little bit easier because there's only one thing on the top and one thing on the bottom. So we've got negative 1 over 7 times x plus 3 when you factor out the 7, which means you've got 3 transformations. It reflects. It also is a horizontal compression by a factor of 7. You could equally as well write that as a vertical stretch by a factor of 1 over 7. Same thing. Now, I'm sorry, this is 1 over 7. And the last thing is plus 3. That makes it go left 3. All right, I want to quickly now show you some graphing. And this is really simple. If you've got 2 over x instead of 1 over x, your asymptotes remain the same. The horizontal is y equals 0, and the vertical is x equals 0. So I'm going to go ahead and put those in as dashed lines. Now when you're drawing this function, instead of going from the center up 1 over 1, you're actually going to go up 2 over 1, and then right 2 over 1. And then you'll go left 2, down 1, and down 2, left 1. So it changes this curve slightly. We have to put 2 dots in instead of 1. It makes it slightly more complicated to draw, but it's really not that more complicated. So over here, when you've got a vertical stretch of 3, the asymptotes have changed because it's gone right 4 and up 1. So the horizontal asymptotes at y equals 1, and the vertical asymptotes at x equals 4. So if I draw those in really quickly, that's at 1. And so the vertical stretch is 3. So from the center there, I'm going to go up 3, right 1, right 3, up 1, left 3, down 1, and then down 1, 2, 3, left 1, and draw in my curves from there. And that's really the only thing that happens here. And so that's the only little caveat when you've got a vertical stretch there, is you put 2 dots in instead of 1. Otherwise, it's exactly the same as last class. The last thing I need to show you, and probably the most important thing, is how to find horizontal asymptotes algebraically. So if you've got a rational function here where the exponent is bigger on the bottom, x squared is greater than x to the 0th, and x to the 3rd is greater than x to the 1st. When it's bigger on bottom, the horizontal asymptote is always y equals 0. So that's pretty simple. If it's bigger on bottom, horizontal asymptote is y equals 0. Now, if the exponents are the same, the leading exponents I should say, like x squared is the same as x squared, x to the 5th is the same as x to the 5th, then you must divide the leading coefficients. So it's y equals -3 over 9, or if you prefer, y equals -1/3 is where the horizontal asymptote is for that one. And here it's going to be y equals 18 over 3, or when you reduce that, y equals 6 is where the horizontal asymptote is going to be. So it's not always going to be y equals 0. Sometimes, if the exponents are the same, then we can find it a little bit differently. We'll divide the leading coefficients. Now make sure you take the coefficient that's on the biggest exponent. Now the last thing you need to remember, well, let's just summarize. Bigger on bottom, y equals 0. Exponents are the same. Divide the coefficients. And the last one, if the leading coefficient is bigger on top, like x to the 7th is bigger than x to the 4th, or x to the 3rd is greater than x to the 1st, then there is no vertical asymptote. Or sorry, there is no horizontal asymptote. We just say none exists. Because this creates something that's called an oblique asymptote, which is like a diagonal or slanted line. And you'll learn more about that in pre-calculus. We're not going to worry about that in pre-AP Algebra 2. So to summarize, bigger on bottom, it's y equals 0. Bigger on, or sorry, the exponents are equal. Y equals whatever the leading coefficients are when you divide them. And bigger on bottom, there is no horizontal asymptote. Alright, so let's just do these real quick here. These appear to be the same, x squared and x squared. And when they are the same, when the exponents are equal, we divide the leading coefficients. So it's going to be 3 divided by 1, which is just y equals 3. Okay. On this one, again, the leading exponents are the same, and when they're the same, you divide the leading coefficients. So this is going to be y equals -1 over 4, and there's nothing to do there, that's it. It's just y equals -1/4, that's where the horizontal asymptote is. Here, x to the 5th is greater than x squared. When the leading term's exponent is bigger on top, there is no horizontal asymptote. It creates an oblique asymptote, which you will find in pre-calculus next year. Last one, this is x to the 0th. So x to the 4th is greater than x to the 0th. And when the leading term's exponent is bigger on bottom, the horizontal asymptote is always y equals 0. Alright, that's all that we did in class on January the 20th. January 21st. Thanks for watching. We'll see you next time.